Our last video in this section is on function notation. Function notation is just another way to rewrite an equation. It gives it a name basically. So instead of writing y equals 3x plus 2, we might instead write f of x equals 3x plus 2. So it's naming the function f. The reason someone would want to do this is that eventually we're going to be working with many functions at the same time, and instead of having something like y equals 3x plus 2 and y equals 2x plus 7 and y equals 5x minus 8, you can name them f of x, and then another one could be g of x, and then another one could be h of x. And then that would make it easier to differentiate between the different functions. So one thing that you should be able to do with this setup is you should be able to answer questions about the notation. So the question on the left, we have f of x equals 2x minus 3, and we want to find f of x when x equals negative 2. What you would do is you would substitute everywhere where you see this x, you would substitute in a negative 2. So f of negative 2 equals 2 times negative 2 minus 3. So the two x's have been replaced with what x is equal to, which is negative 2. Now when you go to simplify this, you're going to leave the left-hand side alone. We're not going to change that at all. On the right-hand side, we'll simplify using order of operations like we've always done. So 2 times negative 2 is negative 4, and negative 4 minus 3 is negative 7. So f of negative 2 equals negative 7. Another way you could write this, you could also write this as an ordered pair, negative 2 comma negative 7. Because recall that f of x is another way to write y. So when you compare this, you can see that the negative 2 is where the x is, and in an ordered pair, the x goes first. And then the negative 7, that's where the y is, and in an ordered pair, the y goes second. The second question is asking us to do something similar but a slightly different order here. They're saying for the function g of x equals negative 5x, find x when g of x equals 10. So this time it's not x equals 10. We're not plugging in the 10 for x. It's g of x equals 10. So we're plugging in the 10 for the g of x. So instead of g of x, we're writing a 10, and the other side is staying the same. There's no g of x on that side, so we're not plugging in a 10 on that side. And we're supposed to find x, which means solve for x. So we're going to use our inverse operations. The opposite of multiplying by negative 5 is dividing by negative 5, and we end up with x equals negative 2. So if I asked you to write this as an ordered pair, remember your ordered pairs are x comma y, and now we've learned that another way to write y is f of x. So you could write your ordered pair as negative 2 comma 10, because the x was the negative 2, and the f of x, or in this case it's a g of x, is where the y would be, so that would be the 10.